Hello everyone, I am Xiao Yang. Okay, in this section, we will mainly look at how to iterate over a collection and also pay attention that when we are iterating, you should not add an element to this collection, right? And also do not remove the element. This is very dangerous. It can easily cause a crash, but if you must remove it, that's not impossible. So how do you remove it? If you have the requirement to remove it, we recommend using this TMap. TAP is more suitable for adding elements in this collection, performing searches or removals like this. It's generally better for our host to store a fixed set of data. Next, we will implement our own. Before implementing, let's return to our ArrayActor class. Meanwhile, in this location, first, use a regions red to simply wrap it up. The use of this red is that it's just so that when we compile, when we are developing, we can simply block out the code because this class actually has a lot of code already. Then if we do this, you can actually use this red marker in its CPP file as well. Let's take a look at the order of these methods. It is on begin play, our original file and header file. Actually, it's best to establish a simple correspondence. Relationship. When you switch like this, it's easier to find the method. Okay, then our method is the same. Let's call it the leave. Looking at this iteration, we call it loop away. So our current requirement is very simple. We need to concatenate this string. Our first method is the one we use most often, but it isn't the oldest way. It should be considered an intermediate method. We usually use it. We discussed this in the code guidelines. Actually, when it comes to all2, in our programming process, there are only two methods, two places where it is used. One is when looping. When iterating over an array, or TMap, we will use all2. Why is that? Because there are some structs, or the type that comes before it in a map. This element type is quite common. If we use all2, it is relatively easy to write directly. And also, there is another place. We are in this example function. When the table is so large, we will use O2. We use O2 quite often in these two places. We'll just add it here. And this place is a fairly integrated video. We don't have this stereoges here. We'll create a stereoges. And then we put it here. And then we create it like this. We'll add one here. Our idea is to combine these strings together. And this is how we get the reference. Actually, if it's regarding this function, we can do it like this. The effect is actually the same. We give this 2 lives, but sometimes it will be different. The advantage of getting a reference is that it saves this saving. It doesn't create this temporary object because it essentially points to these several elements on this side of the number. And at the same time, you can modify your element. But if sometimes you just want to copy it out, if it's an element you don't want to modify, or some other factors, then you don't need to add this reference symbol. We recommend adding all of these references. A name was assigned to this location, right? In fact, the final result looks like this. So let's simply call it up. Okay, there are no problems here. We set a bait. We have started it. Okay, similarly, we just need to modify this method here.
There should be an XP loop LV1 here.
Let's look at the result of its execution. Okay, the breakpoint has entered. These are 2 empty slots, right? No problem here. Then we perform a simple loop iteration here. Oh, the loop is complete. You can see that this one has become Hello World of Tomorrow. So, if we perform a loop here, you will find that their effects are the same, but actually, if we have logs, you'll notice that this spot is because it jumped past. Let's place it here. It has already jumped into reflection. Let's check it again. We'll set it at this location. We'll set it here. Then we finish up. Okay, let's take a look at. Look, this place is also the Hello World of Tomorrow. Okay, in fact, this place is just a simple syntax demo. Then we will proceed to demonstrate this kind of second or third array. Let's take a look at the difference between the two. We will demonstrate them all at once. Okay, then please note that because in this area, if we use red here, it's best to wrap it like this. Like this. Look, you can change this to array region. We agree with the previous name and this one. Other places can be used here. It can be nested once more. Yeah, look at its subsections. This spot should work, right? Let's take a look. It's still here. Okay. We better. If we match them up like this, it would look better. Something like this. You can see. And then a function like this. Let's first copy the code over here. Similarly, let's take this initialized number and copy it over. Then let's also copy it over first. Let's shrink it a little, and then remove this too. Now, let's take a simple look. The second method is our traditional approach. Then we use index. Because we know the maximum number of elements in our array is, its index is from 0 to the maximum number minus 1. So, it's equivalent to if I have 5 elements, then my indices are only 0, 1, 2, 3, 4. This is basic programming knowledge. Then let's note that we are adding index here. Actually, there is a key point for interviews here. It's about ++ index and index +++. Which one is generally better to use? We choose to use ++ index. This involves some C++ knowledge. Sometimes when the interviewer asks, they like to ask about this area. And then you might need to explain this part. This is about the instructions and sequences in assembly. But we don't need to delve into studying this thing with I incrementing and incrementing I. You just need to glance at it before the interview. And this part is actually continuously iterating through this index, starting from 0, incrementing by 1 after each use. When it reaches the final iteration, then it will. That means maybe when it equals the element of this number. For example, when it's the 5th one, it is equivalent to not being a valid index. This will no longer perform the loop and jump out. Okay, so this is the second convenient way. We use the most conventional method. And the third method is quite special. It uses this container. Should be X. It uses an iterator. One was created here. A length iterator. Spawn IT points to the first element of the collection. The first element points to its address. When it iterates to the last time, it doesn't point to this. It points to the address after it. At this point, its pointer is no longer a valid pointer, so we skip out of the loop here. So therefore, and this place repeatedly processes the shown. This data result is displayed, and this is a const. Actually, earlier sometimes we like writing it this way, should also work. The meaning here is that it's a const, which means we won't modify. Just avoid creating a modification. So this acts like adding a const. Then we will execute these two in order. Let's start it. Let's open this area. Then next is the loop. We'll let them run together. Right here. Should be loop or v3. Okay, let's execute it together. This effect should be the same too. We can just click this to start it. That works too. Okay, after you come in, we'll make it loop. Let's set a breakpoint at this location. Okay, this spot achieves the result we want. Then, this place is also the same. So, execute. Because we found that this place also achieves the same result. So, let's assume our current requirement is like this. We need to remove this off element from this input. But we actually don't know what position this off is at. If we want to remove it, we might first need to iterate through a loop. Find the index of this off and then remove it. Then output using a loop. So, is it possible to make it output directly while looping? Actually, it's also possible. Let's first write an incorrect way of doing it. We call it look for away arrow. We generally wouldn't write it with an underscore. This place is mainly to demonstrate the difference for everyone. So let's bring over the first one. Or we paste the second one. Pay attention to it. Then we do this here. If we are at here, wait. If this, just take these 4 strings, we can directly use etc. We can also use this echo. For the standard version, we use equal. We generally like to put the length first. So actually we do it this way, right? So we just use it like this. We just need to see if these two things are the same. If they are the same, we can have it removed. Okay, here we can pass in a string, but we can pass the index like this. Remove and okay, there is one point that we can discuss later. Okay, so it will take the specified. Remove this index. Okay, then let's look at it. Then we won't execute this part afterward. Let's see if this code can achieve our expected effect. Okay, let's start it now. Normally, it should be faster. Let's take a look. It doesn't seem to have a shortcut. Let's check. We'll start it here. Let's set a breakpoint. There shouldn't be a shortcut this time. Let's see if it achieves the desired effect. First, let's go in. Regarding the first element, it's this one of ours. Hello. And then after adding it, it's hello. The second element is word. Skip it. Hello. Then the third element, we consider it to be off, right? It's considered off, then this should be removed. This proves that he removed this element. Then let's go look at this area again. If we look at this element again, I think it should be tomorrow, right? Let's take a look again. Why did it turn into an exclamation mark, right? This proves that the sorting occurred within this host element. It's equivalent to the original index 3. Then we moved forward with tomorrow. And then index 3 became this. And so this is completely incorrect. And this kind of error is actually quite difficult to troubleshoot. Finally, after we queried directly, it was hello world with a parameter number. And there was no tomorrow, right? So this way is incorrect. So actually yours is correct. If you want to process them in reverse order like this, you should remove it this way. We will write one for everyone. It might not be that correct, but it is an implementation approach because it will shrink. It's actually related to this area. This remove, there's a thing here called allow shirking. Whether or not it checks the host. If it's stable after the check, we just let it go to default. Yeah. Okay, so within this, we'll do it this way. First, we also declare it. Then, we also iterate through it, but note that when we iterate, we check it like this. We set it to equal, just use number -1. Then, let it must, its last one should be not equal to 0, right? Okay. It should not be equal to 0. But this could cause problems. If this numerical element is 0, then it's actually -1. So in this way, we make the condition greater than or equal to 0. Greater than or equal to 0 proves that we still have elements. Okay, and then in this part, we subtract. Okay. Then we similarly, so now we are essentially in reverse order. We need to change this addition. We cannot let it. We will still remove this off element. But we are iterating starting from this exclamation mark, so we cannot let it be added to the very front. We will do it this way. Our actual distance equals our current one. We want to let our original actual distance add it to the front. It should be added to this location. Let's think about this area. Okay, we should add it this way, because we originally added it like this. Because we've reversed it now. We originally added it like this. So we add it this way now. Let's see what the execution result will be. Okay, let's set a breakpoint. Okay. We basically run this execution. We just execute. Okay. The first thing that comes in is the exclamation mark, right? Here we add the exclamation mark. No problem. After we come in again, it's tomorrow. It's fine too, right? Let's also add this spot word, right? Turning it off, successfully removed it. Let's take another look. Here, hello world of tomorrow. No problem either. It just connected them all together. It might not look very good. If you want to change this, maybe. This spot is also pretty easy to change. Is when you add it here at this location, add this one, put it here. Let's execute it again. At this moment, our off will be correctly removed. It is assembled in the subtitles. This is also the result we want. This counts backward from the end. Okay, then let's just let it execute completely. Let's look at the results. Okay. Hello world tomorrow. This off was correctly removed. It is no longer this hello world. And it won't remove a tomorrow. So this is the correct way to remove an array element. Right? Actually, during our practical development, we will also write another way. If we have time, we'll show you another one. This is a method that is frequently used during our real-world development process. We call it match2. So in this place, we let it let me take a look. So if we do it this way, we will do it like this. This method, we still need to copy. But in this area, there is a way like this. We call it int3 pin2, and this is called remove index. Remove index. If it is equal to this, we will add it. Add it in. Let's add this index in. Let's take a look. Should be adding it. We'll ignore this one. We won't process it. Then if it equals this, we need to add it in. Then we can write another one here. We add another element. Hello, my word. If it is equal to this mine, we also add it in. Then, after iterating through a reverse loop, it will add the two indices that need to be removed. Right? Then let's do it one more time. This kind of sequential loop. We let it cycle again here. But the index in this place is called the remove index. But it seems a little confused with this thing. We call it RemoveAt to avoid confusion. This place is not equal to it. Then we will loop through this data. Then we sequentially retrieve this index. We can simply remove it like this. Let's take a look at what the effect is after removal this time. Remove and then place it like this. Please note here, it is written like this here. We will place this here. If we seal it, we call remove index array. There's actually a trick to renaming here. You can rename it like this. This way, you won't have to manually change everything. It changes everywhere. Okay, so after removing it like this, then, regarding the expected result, we should simply have this element correctly removed, and simultaneously won't cause any issues. We often do it like this. Later on, we will supplement a core piece of knowledge here. This is the introductory practical session. We will also supplement a survival-style core practice knowledge point. Let's first take a look at the result. Yes, that's him. Yes, he just walked right in. You'll notice there are two elements here. They are the third index and the first index, respectively. And then after we remove them, let's take a look. Let's run it one more time. They should be removed now. After he finished removing it, this result, hello world, tomorrow, my conf was successfully removed. And it also didn't cause any other issues. So this is one of our foundational practical exercises. We will also add another core supporting point. We write it here. That means, note that must be executed synchronously. We will explain this concept in detail later when we cover multithreading. What is this concept? That means when we use the engine's built-in WebSocket, you must not create a new WebSocket during the communication process of the WebSocket. This place must involve a dispute action. You should not, during the entire communication process, send another message. Similarly, for HTTP, you shouldn't do that either. I mean, you receive a response to an HTTP network request. You should not, when responding, create another network TTP. You will miss an entire cycle. You need to execute in the next cycle. So, when you get this data, we will use some special methods to let it execute in the next cycle. If you don't do this, you will cause a crash. The reason for the crash is that this module that manages network communication for all communication requests are in a container. So when it responds to the request, it is actually iterating over this container. If you are iterating over this container during the process, continuing to create this type of request, then there will be a problem. The error code that is generated, this error, it's when you are iterating through a container and modifying the elements inside the container, and addition or deletion like this. Doing it like this is very dangerous. It's easy to crash. Okay? We'll end the lesson here. Thank you, everyone.